Good morning, students. Chapter 11, Thermal Properties of Matter. Yes, here we have discussed topic modes of heat transfer. Yes, there are three modes of heat transfer: conduction, convection, and radiation. Out of these three, we have discussed one, that is conduction. In conduction, heat is transferred from one particle to second, second to third, third to fourth. No actual motion of particle takes place during heat transfer. This point you have to remember. Now, second mode of heat transfer is convection. So what is convection? What is the difference between conduction and convection? The first difference is, in conduction, heat is transferred due to temperature difference and there is no actual motion of particles. In convection, yes, heat is transferred due to actual motion of particles. How? So see, we are taking one example for this. For example, in vessel, okay, here it is fluid. Fluid means any liquid or gases. Fluid. Okay? Yes. Here it is fluid. If we give some heat at bottom, heat, then what happens? See, yes, initially the lower part of this vessel, okay, here it is in contact with this burner, so yes, obviously initially it will absorb the heat energy. It will absorb the heat energy. So this lower part of fluid absorbs heat energy. Its temperature increases. Now as temperature increases, you know thermal expansion. Yes, you know thermal expansion. So as temperature increases, volume increases. And if volume increases, we know one relation, that is density rho is equal to mass upon volume. So if volume increases, density decreases. So yes, density decreases. So this less denser fluid, comparative to this upper part, okay, due to buoyancy, it will move in upward direction. And this fluid in upper part, due to gravity, it will move in downward direction. Yes, it is due to buoyancy. It is due to buoyancy and it is due to gravity. There is actual motion of particles of fluid. Okay, again, heat is given, temperature of this part of fluid increases, its volume increases, density decreases. This less denser fluid will move or it will rise up, it will rise in upper part. While this fluid in upper part having higher density, okay, it will move in downward direction due to gravity. So there is actual motion. Now what happens? So yes, again it absorbs heat, temperature increases, volume increases, density decreases. So this process goes on. Simple. Okay, and due to such motion of particles, the whole fluid, okay, it is heated to some particular temperature. Simple. Okay, so yes, now how to write? See, here it is. It is a mode of heat transfer by actual motion of matter. Yes, that is actual motion of matter. Possible in fluids. Fluid means liquids and gases. Yes, fluid means liquids and gases. Okay, it can be natural or forced. Yes, there are two types of convection: natural convection and forced convection. First of all, we will see natural convection. Okay, yes, this boiling of water. Yes, boiling of water. This process. Suppose gravity plays an important role. When a fluid is heated from below, the hot part expands and therefore becomes less dense. Because of buoyancy, it rises and upper colder part replaces it. This again gets heated, rises up and replaced by colder part of fluid. This process goes on whole fluid, whole liquid, whole gas is heated to some temperature. Simple. Okay. In forced convection, what happens? So in forced convection, material is forced to move by a pump or by some other physical means. Examples are forced air heating system in home, human circulatory system, cooling system of engine. Yes, in our human body, heart behaves as pump. It circulates blood in our body. Simple, it circulates blood, not form, okay? It circulates blood in body. Clear? So yes, it is simple. Okay, what is convection? Due to convection, okay, whenever you are on a bank of sea, okay, you will feel sea breeze, means cool air. Why? So it is due to this convection. Yes, it is due to convection. Okay. So yes, in convection you have to remember these points only. It is enough. Okay. Yes. In conduction and convection, they both modes of heat transfer requires some material. Yes, some particles for heat transfer. But there is one question. Yes. Okay. In our solar system, Sun, it is at center and all planets are revolving in elliptical orbit around it, and we are getting radiations from Sun. See, most of part between Sun and Earth, it is vacuum. Then how energy radiated from Sun reaches to Earth? In this case, which mode of heat transfer is possible? No conduction, no convection, because there are no particles. It is vacuum between Sun and Earth. Okay. So, due to which mode of heat transfer that energy propagates from Sun towards Earth? So yes, that third one is radiation. Okay. Conduction and convection are required some material as a transport medium. But most of region between Sun and Earth consists of vacuum only. Then how does the solar energy reach the Earth? Yes, it is due to radiation. Okay, the third type as well as of heat transfer is responsible for making the solar energy, solar heat to reach the Earth. And this type of heat transfer is called the thermal radiations. Yes, thermal radiations. Now what is thermal radiation? That is question. Okay, what is thermal radiation? So see, every substance emits electromagnetic radiation of certain frequencies in accordance with its temperature. Now we will discuss in detail about this. Okay. Okay, so now we will see what happens when object is heated. Every substance, accordance with its temperature, it emits radiation. Suppose you are given one object, and suppose this substance is heated up to temperature T, then according to its temperature, it emits some radiations. And such radiations are called thermal radiations. This radiation is known as thermal radiation according to its temperature. Okay. Thermal radiations are electromagnetic radiations only. Now what do you mean by electromagnetic radiation? Electromagnetic waves. So yes, electromagnetic waves that does not require any medium for the transmission from one point to another point. Electromagnetic name is given because they produces electric field as well as magnetic field. That we will see in 12. Okay, in detail. So right now you have to accept this. Okay, according to temperature, according to temperature, every substance emits some radiation called thermal radiations, and they are nothing but electromagnetic radiations. Energy associated with electromagnetic radiation is called radiant energy. This points you have to remember, okay? Each substance continuously emits thermal radiation at some temperature, at any temperature. Yes, any temperature, it will radiate some energy, okay? Each substance continuously emits thermal radiation at any temperature, and according to its temperature, it emits waves, electromagnetic waves of particular frequency, So yes, according to temperature, it emits waves or radiation of particular frequencies, Clear? So this point you have to remember. Now what is reason behind it? Okay, according to temperature it emits radiation of particular frequency. That we will discuss in 12th. Yes, that we will discuss in 12th. Okay. Now what happens? See, if you are given one substance like this. Sorry. Okay, if you are given one substance like this. If we increase temperature of this substance, then the rate of emission of radiation also increases. Yes, if temperature increases, rate of emission of radiation also increases. This point you have to remember. Okay, as temperature increases, rate of emission of radiation also. Rate means what? Okay, it is energy radiated in given time. Rate means in time, in some particular time. What is power? It is rate of work done. Okay, in such time, what is work done? So similarly, it is energy radiated in given time. Now, listen. It is not always one condition that every substance only emits radiation. Every substance emits radiation as well as they also absorb radiation. Yes, as well as they also absorb radiation. So substances also absorb energy or radiation. We can say radiations. Okay, so what happens? Okay, if this object it absorbs some energy, it is emitting some energy, then what happens? So see, we are taking some cases. Okay, case 1. Okay, if you are given one body, for example, okay, rate of emission means it emits some radiation at some rate. Okay, rate of emission means it emits radiation. Also, rate of absorption. It absorbs some light. Okay, rate of absorption. So yes, every substance is under the effect of these two conditions. Okay. What about their temperature? When the object emits as well as absorbs energy. So yes, according to this, we will have three conditions. First, okay, if rate of emission is greater than rate of absorption, temperature of body increases. Temperature of body decreases. So this first point you have to remember. Okay, when rate of emission is greater than rate of absorption, then what happens? So yes, temperature of substance decreases. Second case, Okay, if rate of emission is less than rate of absorption, then what happens? So yes, in such case temperature of substance increases, because rate of absorption is more, means it will absorb more and more energy and it is not emitting more energy, so yes, its temperature increases. While in third case, what happens? So yes, in third case, okay, if rate of emission is equal to rate of absorption, then yes, if these both rates are same, means its temperature remains same. Same means it is in thermal equilibrium with surrounding. Thermal equilibrium means temperature becomes same. Okay, so yes, for radiations you have to remember this point. Okay, any substance according to its temperature radiates some energy. It is nothing but electromagnetic waves. For waves characteristics is frequency, or you can say wavelength, that you have already discussed in chapter number 15, waves. Okay, so waves, see, there are numbers of different types of waves: X-ray, ultraviolet light, visible light, etc. They all have same speed, that is 3 to 10 to 8 meter per second. Okay, and they all are called electromagnetic waves. So remember, according to temperature, every substance emits some radiation of some particular frequencies. Okay, as temperature increases, rate of emission of radiation also increases. These three conditions you have to remember. Okay, now absorption and emission, it depends on material. Okay, which type of material you are given. Not every substance will absorb energy. Not every substance will absorb all energy incident on it. Whenever energy is incident on any substance, then it is partly absorbed and it is partly transmitted. Yes, it is partly transmitted. What happens when energy is incident on substance? If it absorbs all the energy, then which type of body it is called? We will see in next lecture. Yes, there are numbers of definition related to this point, that is called radiation, and in next lecture we will see the same thing. Clear?